So you may well be aware of this already, but in the same way as if you want to send a parcel or a letter to someone's house, it has to have a unique address, otherwise it can't get to where it's going. And that's the same on a network. So every device on a network has to have a unique address, and those addresses are known as IP addresses. And the most common ones that we usually see are those IPv4 addresses, and the one in the middle is an example of that. And they're made up of four what are called octets, which are, take that name from the fact they're made of 8 bits each. And that gives us the value 0 up to 255 to work with in each of those four little bits. Okay. Now, that therefore gives us a 32-bit number to work with, and therefore that gives us about 4.3 billion possible IP addresses, give or take some. Okay, now that's fine, but if you then think about the number of devices on a very large network like the internet, it's going to quickly get more than that. So to try and combat that, we have other versions of this as well. So, for instance, we've got IPv4, V6 rather, to replace V4 is what I meant, which takes the number of bits and increases it quite substantially to 128-bit. And if you look at the bottom of this little table, we've got the number of possible addresses, like you see in the V4 one, that's about 4.3 billion. The V6 is staggeringly bigger, so the number of possible combinations is huge. Doesn't necessarily mean that we've all of a sudden started using V6. As you can see, it was first deployed just before the turn of the millennium, and we still don't really see it. And if you look later on, you'll see possibly in some other videos as to reasons why that is and how we've actually managed to stay with V4 in a lot of actual implementations.